Thank you so much. As Elise just mentioned, I'm Jackie Beck. I'm a PhD candidate at The Ohio State University. And today I'll be telling you about the soil moisture data value study sensitivity analysis that we conducted in the UMRB. Before we get into how we did this and the results, I do want to acknowledge all of the people who helped on this project. They include Gavin White, Ileana Dobreva, as well as Stephen Quire. So to kind of introduce you into this topic, we've talked about it a little bit throughout the week, or excuse me, over the last few days. But this project is a result of extensive flooding that happened in the basin back in 2011. As a result of this flooding, it had a lot of impacts in the form of the agriculture industry, as well as transportation and tourism in the area. As a result of that, they are installing 462 stations across this blue shaded area on the map. And according to the appropriation that I found online, the cost of this is a little upwards of $55 million. The goal of this work is to have this done by 2027. However, we do kind of want to see like what are the positive impacts of this work. So to get into the data and methods of this work, the upper map that you're seeing is the initial network of 78 stations that are located in the UMRB. And the second map below that is what this map could look like once all 540 stations are installed. Currently, not all of these are installed. They're in some different stage of the installation process or are currently being sited. So we do have hypothetical stations. Those are the stations that you see in red. And those all fit within one grid cell. We talked to the people who are working on siting these stations and we'll follow their guidelines to make sure that they're approximately 22 miles apart, so that this actually is somewhat similar and representative of what is going to happen with this. Since a lot of these stations are still in process, we use the NIDIS data set for your soil moisture to get a time series of this. Our analysis is based on 2017. So we took and forwarded each station that is going to be there, or is currently there. We pulled an NIDIS grid cell for that to simulate what the station will be and get a time series for that data. And that is our initial network locations, which that is the 78 stations or 78 grid cells. And then for our expanded network, it is 540 grid cells that went into that interpolation. We used a regression Kriging interpolation method for this. And from that, we were able to classify drought conditions based off of the two different station densities. We used a high-key skill score to evaluate the improvement in the skill based off station density. We also looked at the spatial difference, as well as the drought severity area that is being classified based off of the station density. Beyond that, we also looked at what the economic impact of this could be from adding these stations. So we took the drought classification from both the RK prediction from the expanded and initial networks, the pay rates from 2018 for the upper Missouri Basin through the USDA, as well as the number of livestock available in the 2017 US Census of Agriculture, and from that calculated payments of what it would look like based off of the two different station densities to compare them. We conducted this analysis at 520 as well as 50 centimeters. Today we're going to be showing the 20 centimeter results. However, if you're interested in the others, they will be coming out in a paper sometime early, probably next year. So here on the left, we have the reference data set. This is the full NIDIS data set that we pulled for the entire basin. From this, we can see that is our truth simulation being the reference. There was no drought 65% of the time. The rest of the time, there was some form of drought. Most of it was located up in the northwestern portion of the basin, with D1 drought quantifying at 15.5%. D2 and D3 being around 8%, and then D4 being at 2.6%. Based off of the initial network RK classification, there was a little bit of differences. As we can see up in the northern part, we're not seeing any D4 that was classified. There was very little D3 that was identified. And then D1 and D2, there's some differences and increases, with this D1 being over 14% over what we would have expected. With the expanded network, it did make a lot of improvement. It is not perfect by any means, but at that point, we can see that the classification of no drought is within 0.6 of the reference data set. The D1 classification is within 5%. Excuse me. D2 is within 2%, D3 within 2% as well. And at this point, we are starting to see some D4 that is being classified. However, it's still not ideally where we'd like it to be, but this is a huge improvement based on these classification levels. If we look at the differences from this, across all of 2017, most of the misclassifications were between 1 and 2 categories for the state, which that we're looking at, which is in September 12th of 2017. The initial network got about 67% of the basin correctly classified. The expanded network bumped that up over 10% to 77% of the 1 to 2 classes. Overclassification was about 11% for the initial network. It was a little bit higher for underclassification at 20%. And then the 3 and 4 classification misses were much smaller at about 1.5%. When we move over to the expanded network, all of this tends to improve, especially in the 1 to 2 category over and under predictions. It drops between 5 and 3%. And then we're not really seeing very many 3 and 4 classification differences, with that coming in just under 0.5% for all those categories. To look at our high key skill score difference, almost all of the basin improved. So we had 98.3% of the basin that improved in score, excuse me. With this, we're seeing the change in the basin. So a lot of the change was located in the southern portion. Those red colors that you're seeing are the positive changes. The gray colors are the slight differences and declines from the 2 predictions. Most of the predictions that we do see, anything you're seeing in white is usually between 0 and 0.5. However, there were some big jumps. About 22.48% of the basin improved between 0.15 and 0.25 in score, and then 34% of the basin improved over 0.25%. The maximum improvement that we saw from the increased stations was about 0.57%. Which is very significant. We're seeing a lot of improvement from this. Looking at the LFP payments that we calculated based off of these drought classifications, the reference data set classified $682 million in payments that should have been issued over the basin. With the initial network, it estimated payments at just around $480 million. Which is an underpayment of $202 million, which is very significant for the producers who are in this area. 23% of counties were underpaid. If we look at what the blocks of who was making up this, 16 counties were underpaid between $5 and $10 million. And then 3 of those counties were between $10 and $15 million on the underpayment side. 69% of counties were paid correctly, which is good that they were compensated appropriately. And then 8% of the counties were overcompensated during the year of 2017, according to our hypothetical payments. If we move to the expanded network, there's a lot of improvement. At this point, we're only underpaying by around 47 million. The estimated payments for the expanded network were 635 million. That is a payment error of around 6.9%. When we break that down, 14% of counties were underpaid. And looking at those payments, 6 counties were between $5 and $10 million, and 1 county was between $10 and $15 million. 77% of the counties were compensated correctly, so that was a 10% increase from the initial network, and then there was a slight increase in overpayment from moving from 7 to 9%. This study quantified the value of expanding the network of stations from the 78 stations to the 540 stations. In that, we found that the error decreased by about 25%. The increase in variance that we were able to explain was about 15%. And if you were to take and expand the network up to 1,000 stations in the basin, it would still be less than 90%. But overall, we did make some huge improvements. Looking at our conclusions, 98.35% of the basin, the skill for the drought classification improved. The southwestern basin, it was where we saw the greatest improvements in drought classification. The payment error changed from 29.6% down to 6.9, increasing the number of stations. And if we look at what the initial investment was of the $55 million in 2017 alone, this investment would have paid itself off by 3 times. So before we wrap everything up, I want to make sure I acknowledge all my collaborators, Dr. Firing, Gavin White, as well as Ileana Dabariva, as well as all the help we had on this project. This was a multi-year project that a lot of people helped with, including Dr. Dennis Toddy from USDA Climate Hubs, Chad McNutt from USDA Farm Service Agency, Catherine Weichman from University of Montana, and Kyle Bahanski from the University of Montana. Thank you.